Sitting in his lab at the École Normale in Paris, chemist and scientist Louis Pasteur was gripped by a new chemical observation that would end only with a revolution in modern science. Eilhard Mitscherlich, a German chemist, released a memo in 1844 claiming that there existed for science an impassable problem. Two acids were found, identical in all chemical and physical respects but one. One rotated a plane of polarized light, whereas the other did not. What could possibly cause this difference between the two acids, which was wholly unknown to scientists of that time? Whereas most scientists were looking for the answer within the chemistry of the acids, Pasteur knew that he would have to look beyond the bounds of mere chemical details. He would have to introduce a new conception into science. Since Newton, a dangerous belief has developed in science, namely that all physical science, plant and animal life, and even the human mind are reducible to simple mechanisms. But such a mechanical view of the physical universe, and the mind of man in particular, left out the willful power of man to act on the universe, reducing him to a condition of slavery under the control of imperialist circles. When Russian biogeochemist Vladimir Vernadsky entered the scene at the turn of the 20th century, this reductionist school had grabbed hold of scientific thought. Vernadsky knew, as one should recognize still today, that this idea was the worst of all intellectual diseases and would ultimately lead to the death of science and consequently the disappearance of a future for mankind. In his studies on the geochemical history of the Earth and the role of living organisms on our planet, he grounded himself firmly in the work of the French scientist Louis Pasteur. Vernadsky saw in Pasteur a way out, a fundamental proof against this fixed view of the universe. He saw in Pasteur's work a principle of life, which organized the physical processes within it, and was in no way reducible to non-living parts. Albert Einstein's fundamental proof that Newton's fixed space and time did not exist helped Vernadsky to develop a new concept for the way the universe is organized. He called this new concept the state of the space of life. In 1808, Étienne Louis Mallieu, a French scientist, made a fundamental breakthrough in physical science. It was known that Iceland's spar creates a double refraction as light passes through it. One evening, as Mallieu watched the sunset through a crystal of Iceland's spar, he noticed something curious. Later, after the sun had set, he observed the reflection of a candle in a bowl of water. The two beams that normally appear in the crystal were there, but as he rotated them, one slowly disappeared, then reappeared as the other subsequently disappeared. As Mallieu realized what he was seeing, he understood that reflected light, when viewed through Iceland's spar, exhibited unique properties. At certain angles, it could be entirely blocked. He hypothesized that the light beams coming through the crystal and the light from the reflection must have been separated into individual planes. When one of the images of reflected light from the candle disappeared in the Iceland spar, he thought its plane had been blocked by the plane of the crystal. Mallieu called this phenomenon polarization. François Arago, in 1811, continued the experiment by shining polarized light through quartz crystal while observing it through a crystal of Iceland spar. He noticed that both of the images in the Iceland spar were different colors. Where did this difference in color come from? Arago explained that the quartz must be rotating the polarized light. The action of the quartz itself changed the light. Trailing on these discoveries, Jean-Baptiste Biot invented the first polarimeter, an instrument which he used to test the optical activity of substances. By utilizing the phenomenon of polarization from Mallieu, he was able to control the plane of light coming through the apparatus, allowing him to test when the light was being changed. Biot, while studying quartz in his polarimeter, found that some quartz crystals rotated the light to the right and some to the left. The light was always rotated by the same angle, but in opposite directions. He named the two types of quartz crystals right-handed and left-handed. At the same time, another French mineralogist, René Just Houy, observed a peculiar phenomenon in the crystal structure of quartz. It had long been known in the study of crystalline symmetry that some crystals, though they are nearly perfectly symmetrical, grow with a very specific defect, such that they have no axis of symmetry. This was called hemihedrism. Houy recognized that his quartz crystals were not only hemihedral, but they exhibited two, and only two, distinct forms of hemihedrism, a right-sided and a left-sided form, which were mirror images of each other. He named these two forms of quartz right and left plagiohedral. Across the Channel, in the Queen's England, John Herschel, son of the great German composer and astronomer Wilhelm Herschel, asserted that there was a correlation between Biot's optical rotation and Houy's hemihedrism. He found that all left hemihedral crystals rotated light to the left, and all right hemihedral crystals rotated light to the right. Therefore, the cause of the optical rotation, he thought, was due to the particular crystalline structure. It would take further developments for the significance of this idea to be fully realized. Meanwhile, in Paris, Biot continued his work on the cause of the rotative power. He showed that it was not only quartz crystals which rotate light, but that a group of solutions, though they were not crystals but liquids, rotated polarized light as well. For example, oil of turpentine, sugars, camphor, and tartaric acid. The common characteristic of these solutions was that they were all products of life. There is one more necessary element. Quartz, which rotates light when shown through its crystal, immediately loses its rotatory power when it is melted, crushed with a hammer, or dissolved into a solution. It is not a characteristic of the quartz itself which rotates the light, but a characteristic of its crystalline space. But, as Biot found, certain liquids do in fact rotate light. Biot had already recognized there was a significance in the fact that only organic substances, substances which come from life, could rotate light in solution. But the role of life here was still far from being understood. One of these organic substances which he experimented with, tartaric acid, garnered enormous interest. In 1770, tartaric acid had been discovered in the leftover crust known as tartar, in barrels of wine after fermentation. However, in 1820, a curious discovery was made. Due to an accident in his factory, a tartaric acid manufacturer in Thann, France, Karl Kessner, found amidst his tartrates some unusual tufts of needle-like crystals. After separating these, he saw that though these tufts were chemically identical to the rest of the tartaric acid, they were not exactly the same. Additionally, all his attempts to recreate the unknown acid failed. Chemists from all over rushed to study the acid at the factory in Thann, including such as Berzelius and Gay-Lussac. But all failed just as miserably in their attempts to understand it and in their attempts to reproduce it at will. This curious substance was named racemic acid. In 1844, the German chemist Eilhard Mitscherlich released a document revealing the most startling evidence of all.
The racemic acid and the tartaric acid have the same chemical composition, the same crystal form, the same specific gravity, the same double refraction, and therefore the same angle in their optical axes. Their water solutions have the same angle. But the dissolved tartaric acid rotates the plane of polarization, while the racemic acid is indifferent to it.
Young Louis Pasteur, at the time a newly admitted student at the École Normale in Paris, had followed these developments carefully. Two acids, totally and completely identical in all of their chemical and physical properties, except that one rotated a plane of light and the other did not. What could account for such a difference? Biot had hypothesized that the cause was in the molecular structure of the acid itself.
This conclusion at the time of its publication especially concerned me. I was at the time a scholar at the École Normale and studying during my spare time the interesting investigations upon the molecular constitution of bodies, and was, as I at least believed, beginning to understand the generally accepted principles of physicists and chemists. Mitscherlich's communication upset all my ideas. What similarity in all respects? Are there two bodies, the properties of which have been more thoroughly and carefully compared? Can there be, in the present state of science, two bodies so entirely similar without being entirely identical? Mitscherlich himself tells us what must follow from the similarity. The nature, the number, the arrangement, and the distance of the atoms from one another are the same. In short, this communication of Mitscherlich's remained in my mind as the chief difficulty in the way of this conception of bodies.
One day, while walking with his best friend, Charles Chapuis, in Paris, Pasteur mentioned his recently sparked interest in tartaric acid and its mysterious twin racemic acid. Chapuis gasped. He could not believe the words that came out of his friend's mouth, for he knew very well the disturbing mystery and tantalizing appeal that these two acids presented to scientists. He refused to let Pasteur get pulled into what had turned into an endless quest for answers for so many, pleading with him to drop the quest and continue with his studies. Pasteur, however, despite Chappuis's efforts, remained enthralled by the paradoxes the acids presented. Pasteur took up a study on all aspects and derivatives of tartaric and racemic acid, provoked to delve even further into the mystery of the tartrates. During one of his experiments, a shocking insight struck Pasteur. All the tartrate crystals were hemihedral, an observation which no one had made before. The young scientist was ecstatic. Here was the clue that would lead to unveiling the mystery of racemic acid. Thus, with Herschel's hypothesis in mind, that there must be an underlying cause for both the hemihedry and the optical rotation in the tartrates, a dissymmetry in the molecular structure, Pasteur followed his intuition.
Mitscherlich was deceived in affirming that the crystals of the tartrates and the racemates resemble each other. There must be some external differences as regards these hemihedral facets. Mitscherlich would not have seen these differences, which he did not seek, but I, who have the preconceived idea of their existence, am in a good position to find them if they are there.
Because there was no optical rotation in the racemates, he thought there would consequently be no hemihedry. That is, the molecular structure of the crystals would remain symmetrical. At once, Pasteur replicated Mitscherlich's experiment and crystallized racemic acid.
But, unexpectedly, the racemic acid salt was also hemihedral. However, the hemihedral faces in the tartrates all lay in the same direction, towards the left. In the racemates, some lay towards the right, and some towards the left. In spite of the completely unexpected character of these results, I, nonetheless, followed my idea. Taking all the racemic crystals, I separated carefully the right hemihedral crystals from the left, and observed the solution of each by itself in the polarimeter. There I saw, with as much surprise as joy, that the solution containing left hemihedral crystals turned the plane of polarization toward the left, and the solution containing right hemihedral crystals turned the plane of polarization toward the right, and that when I took an equal mass of both crystals in solution, the mixed solution, that is half right hemihedral and half left hemihedral, remained inactive toward light, through the mutual compensation of the two equal but opposite rotations. The publication of these facts brought me naturally into communication with Monsieur Biot, who entertained no doubt as to their correctness. Since he wished, however, to discuss these before the Academy, he invited me to come and repeat the different experiments before him. He gave me some racemic acid, which he himself had previously examined and found to be entirely inactive toward polarized light. The solution was then placed in his laboratory and allowed slowly to evaporate. When 30 to 40 grams of crystals had separated, he called me again to the Collège de France to collect and distinguish by their crystallographic character the right and left rotating crystals from one another, under his direct observation. He bade me repeat the declaration that the crystals which I placed at his left hand would rotate the plane of polarization to the left, and the others would rotate it to the right. After this had been done, he declared that he himself would complete the experiment. He prepared the carefully weighed solutions, and when he was ready to make the observations in the polarimeter, he called me again into his laboratory. He first put into the apparatus the most interesting solution, the one which should rotate towards the right. Without making a reading, but upon the instant, he noted a change of color in the two halves of the field of vision. He recognized an important right rotation. Then the excited old man seized my hand and said, "My dear child, my whole life I have loved this science so much that I can hear my heart beat for joy."
Pasteur had found that the racemic acid was in fact an equal mixture of both left-handed and right-handed tartaric acid. This was the first time that the right-handed tartaric molecules were known to exist. Pasteur concluded that any handed molecule which rotates light to one side must always have in potential an oppositely handed pair, though that particular handedness may not be present. Thus, the modern concept of handedness or chirality was established. Two absolutely identical but oppositely arranged handed molecules exist for all substances, though, as in the tartaric acid, only one hand may be present. The obvious question here is, why is it in some solutions such as tartaric acid, only one hand is present, while in others such as the racemic acid, both hands are present equally? To answer this question, Pasteur went back to the process which had created this paradox in the first place, fermentation. For thousands of years, human society has used fermentation for winemaking, beer, and food. But nobody really knew what this strange process was. Was it a chemical reaction which caused sweet French grapes to sour and turn into wine? Was it a catalytic factor in the yeast itself, which caused dough to rise and bake into fresh, warm bread? Pasteur hypothesized that perhaps the answer to the curious difference in the tartaric and racemic acids must lie in the same phenomenon that caused the process of fermentation itself. In one experiment he carried out, he fermented a solution of racemic acid. Naturally, at the outset, it was inactive towards polarized light. But as the fermentation continued, he began to see a subtle rotation to the left. This continued to increase as the fermentation proceeded, until the solution reached a maximum left optical rotation, at which point the fermentation stopped abruptly. Pasteur evaporated this final solution and found that only left-handed crystals remained, where there had been an equal amount of both left and right before the fermentation began. The racemic acid had seemingly turned into the tartaric acid. Out of the two possible handed forms which compose the racemic acid, it was as if the yeast, which Pasteur hypothesized was a living process, had literally consumed all of the right-handed tartaric acid and had no appetite for the left-handed form. How was the yeast distinguishing between the two forms of the acid? Did every yeast have its own polarimeter to test the food before eating it? If so, these must be some snobby white-collar yeast. Rather, Pasteur understood that here was perhaps the clearest distinction between life and non-life. Under all non-living conditions, that is, without a process of fermentation acting on the racemic acid, the left-handed and right-handed tartaric acids behave identically in all respects, except for the direction in which they rotate light. However, to a living process such as fermenting yeast, the two forms are as different as night and day, to the point that the yeast chooses only the right-handed form, ignoring the left-handed form completely. Therefore, tartaric acid would only appear in, and was only a product of, living processes. Think of two screws, one spiral to the left and the other spiral to the right. When screwed into wood with straight grain, they behave identically. But when screwed into wood with a right or left spiral to its grain, the grain itself, the way that the space of the wood is organized, determines which screw can enter into the wood. Thus, as in this analogy, the space of life, its organization, is also dissymmetrical. Vernadsky knew that Pasteur's discovery of this dissymmetric property of life was an important part of a larger idea. No amount of fermentation by living processes will give an equal amount of left and right-handed forms, will create racemic acid, because it is precisely these living organisms which are dissymmetrical. Vernadsky called this the Curie principle, that a dissymmetrical effect must have a dissymmetrical cause. In this way, we see the clearest distinction between the space of life and the space of non-life. No amount of non-living physico-chemical processes combined in any way will add up to create a living organism, just as a dissymmetrical space can in no way be created from or reduced to symmetrical space. Even if certain aspects of non-living processes may appear to have similar characteristics to those of the living, such as the handed forms of quartz, these are merely effects. Vernadsky showed all living matter is generated by a process which is outside of and above any physical mechanism. It acts as if inspiration to the bodies which it influences. On the heels of these discoveries, Vernadsky saw clear physical and experimental proof for a new revival of Francesco Redi's principle. The living must always be born of the living. These breakthroughs in biochemistry at the end of the 19th century led Vernadsky to formulate an idea that at least 3 physical phase spaces operate within the universe: the domain of the abiotic, or non-living, the domain of the biotic, or life and its byproducts, and the noetic, the domain of human creative thought. As Vernadsky demonstrated, these domains are not only not reducible to one another, life cannot be reduced to non-life, but there is a definite directionality to them as well, with life bounding and organizing the non-living domain, and human creative thought, advances in scientific and technological breakthroughs, organizing and bounding both living and non-living processes in the universe.
Creativity is located in culture. It's located in the experience of discovery, embedded in the evolution of ideas. And the evolution of ideas which becomes communicable and reflected in the conversation, in language, in artistic language, artistic expression, and similar kinds of language. So every people has in its language a repository of the potentiality mental potentialities associated with the use of that language. You have to use the culture to recognize that in the culture is the repository of the elements from which you can adduce what you are capable of thinking. Everybody can develop. They can develop ideas which they have not previously known, but they develop it from a baseline. They start from a different origin to a common result. So therefore, mankind has to be organized on the basis of a common result achieved through the interaction of different cultural trends in terms of language cultures. And globalization is hell. So the first thing we have to do is to restore the idea of culture. To restore the idea of culture, you've got to recognize language culture. Look, when you get in stress, and you have to come up with ideas, and search inside yourself for ideas which are possible solutions to problems you've not faced before, what are you looking for? You're looking inside yourself. You're looking inside the cultural potential that you have inside yourself, which is almost semi-conscious or unconscious. You're looking for it, which will enable you, as if by surprise, to get a kind of thinking, a kind of idea you never thought you had before. Therefore, without promotion of culture, and without promotion of classical artistic composition, which is the natural expression, healthy expression of culture, you have destroyed the ability of the human mind to develop valid ideas of discovery. So that's the first thing we have to do. We have to realize the problem of culture is what's been done, especially since the death of Roosevelt, done by the Congress for Cultural Freedom, for example, by pestilence, by existentialism, by what's taught today. We have destroyed people's mind and morals by this process. So we have to go back to the root. The root lies in national cultures, language cultures. Because without mastery of language culture, which is what poetry and music does, without that, you don't have creativity in society. You don't have a literate imagination. You don't have self-consciousness of the type you require to sustain creativity.
Look back on the story just told, but not solely as a history of science. Rather, think upon what has been told as a story of man and man's relationship to man. It is the social process or culture defined by individuals such as Pasteur, which constantly determines man's relationship to the universe. What distinguishes this social process from any other non-human process is the principle of immortality, the individual's ability to make a contribution to the future, which lasts even after they die. And for someone alive today to learn from and improve upon the contributions of someone from a time past, whom they have never personally met, making the identity of that past human being immortal. For where would Pasteur be had he no Biot or Herschel before him? And how would Vernadsky have made his breakthroughs without a Pasteur before him? But let us look at this from the other side as well. What would be the significance of Biot's life's work had Pasteur not lived to advance his work? And would the real substance of Pasteur's work have been lost forever if not for Vernadsky? What will it mean for these great minds if we fail to immortalize their ideas today?
piangere non va.